Hi, this video is going to introduce you to the idea of rate of change. The learning goals for this video are to be able to explain the concept of rate of change and then also to calculate rate of change from a graph or a table and explain its meaning. So rate of change is really just how quickly one variable changes compared to another. So here, for instance, we're going to look at the earnings of Mario and Luigi. Looking at this graph here. So you see on the graph here we have earnings on the y-axis and then we have time worked on the x-axis. So if we just kind of examine the graph of Mario and Luigi, they both start off at $10. So for some reason they make $10 right at the beginning just for showing up. And then let's just look at Mario, for instance. After 2 hours, he's earned a total of $40. So really, from the beginning, compared to the beginning, he earns $30 more, right? So we can think about it as his earnings have increased to $40. So that's an increase of $30 over the span of 2 hours of working. So if we look at Mario, okay, we can describe that situation like this. He earns $30 more right, after 2 hours of work. Now, if you do that, you can just divide the values here to find out how much he earns per hour. He would earn $15 per hour. Let's take a look at Luigi now. Let's just go somewhere else on the graph here. Let's start from here. It doesn't actually matter where you begin. So after 3 hours of working, Luigi has earned $40. And then let's just take a look over here. So after 5 hours of work, he's earned $60. So during that span, he went from having $40 to having $60. So that looks like an increase of $20. And in order to do that, he had to work 2 hours as well. So if we look at Luigi, it seems like he earned, right, from 40 to 60. So he earned $20 more after working 2 hours. And if you divide those values, you're going to get $10 per hour. So if we take a look at how we figured that out, I drew these little triangles here. And the number that they earned, or the amount that they earned, I found through the up and down value of this triangle here. And we call that the rise. And the side-to-side part of this triangle, that's the amount of hours they worked, well, we call that the run. Okay, we call it rise because it goes up and down like the sun, and the run is side-to-side, kind of like someone running. And in order to calculate the rate that their earnings change, what we did was we divided the rise with the run. So to calculate rate of change, it's a simple calculation. To calculate rate of change, we do rise divided by the run. And we usually call that rise over run. It's just an easy thing to say. Okay, and we did the same thing with Luigi. Remember, we divided the rise with the run. So that's really the main concept. If you have a graph, it's great to draw these little triangles in order to calculate the rate of change. Now, I'm going to show you a different method over here, where we don't really count on the triangles because you're going to be given other representations of time or earnings and time worked. It's not necessarily going to be a graph, so I want you to know how to calculate rate of change if you are given a graph or a table of values, for instance. So let's just look at Mario and Luigi again, and I'm going to highlight those points that I used before. Now remember, Mario earned $30 in 2 hours. Now, we can get those same numbers by describing these points using what we call an ordered pair. So every point along a graph here like this can be described using two numbers. One number is where that point lies on the x-axis. So you see this point here. If we go all the way down, it lies on 2 on the x-axis. And if we go to the side, it lies on 40 on the y-axis. So this point I can describe as 2, comma, 40. So it's kind of like Battleship, if you've ever played Battleship. Now, this point over here at the very beginning, that point lies along 0 on the x-axis and along 10 on the y-axis. So I can describe this point as 0, 10. Now remember, again, Mario earned $30 in 2 hours, so it's really easy to see where the 30 comes from using these 2 points. We can do 40 minus 10 to get 30. And then also to get 2 hours, well, we can do 2 minus 0. So remember, to calculate rate of change for Mario, okay, we're going to use rise over run. Now, in order to get the rise, remember I just said that we have to do 40 take away 10. Those are the y numbers of each point. So what we're doing is we're finding the difference in the 2 y numbers. I'm just going to write that quickly. We're finding the difference in the y numbers. And then we're going to divide that by the difference in the x numbers. That was 2 minus 0. So I'm going to write here difference in x. So if we do that calculation here, the difference in the y, I'm just going to subtract the 2 y numbers. So that's 40 take away 10. And then for the difference in the x, I do 2 take away 0. So if we do that really quickly, 40 take away 10 is 30 divided by 2, and that's equal to 15. And well, the 30 was dollars, the 2 was hours again, right? So that's dollars per hour. And we can do the exact same thing with Luigi. So we looked at when he made $40 in 3 hours and then $60 in 5 hours. So again, I can describe those 2 points using ordered pairs. This point in Luigi can be described as 3, 40. And then this point here would be 5, 60. Okay. Now, something that really helps is, let's say, if you have 2 points, you can write them on the side like this, 5, 60 and 3, 40. Now, the difference in the y, remember, we're just going to subtract the 2 y numbers, so it lines up quite nicely if you write them on the side here. So, again, in order to calculate rate of change, we're going to do rise over run. The rise is, again, just the difference in the y numbers. So I'm going to write 60 take away 40. And then 5 take away 3 is the difference in the x numbers. So 60 take away 40, that's 20, and that's $20. And the run is 5 take away 3, that's 2, and those numbers as a run are hours. And then 20 divided by 2 is again 10, so it's $10 per hour. Okay, so we get the same answers, but we did it in a pretty much a totally different method here. We used points in order to calculate the rise and the run. So let's just try that using another example here. We've got 2 cell phone plans, and we're going to calculate the rate of change in cost per month for both Bell and Telus phones. So for instance, so we've got a graph here where the y-axis is cost and the x-axis is months on a cell phone plan. So again, we're going to pick 2 points along each graph. So let's look at Bell, and it doesn't matter which 2 points you pick. So it's always easy to pick the first point, and then we'll pick another point that's really easy to read off on the graph. So this point over here would be a good one. Okay. So I'm going to write down those 2 points as ordered pairs. So this one here I can write as 4, 400. So I'm going to write that here, 4, 400. And then the second point is 0, 100. And so the rise over run is, again, the difference in the x numbers. So it's just the last number of each point. So that's 400 minus 100 divided by 4 minus 0. Now, if we do that, that'll be 300. And the rise is dollars here. So I'm going to write dollars divided by 4 months. And then so 300 divided by 4, I'm just going to do that real quick. 300 divided by 4, so that's 75. So that's 75, and that's dollars per month. All right, I'd like you to try to do the same thing with Telus. So if you could pick 2 points, actually I'll pick 2 points so that we have a common discussion about it. So let's pick the first one and this point right over here. Okay. So what I'd like you to do is write down the 2 points as ordered pairs and then calculate the rise over run and see what the rate of change is for the cost per month for Telus. Okay, so pause the video and give this question a shot. When you're ready to check the answer, press play. Okay, good luck. All right, so the 2 points for Telus, this point here at the end would be 4, 300. And the second point would be 0, 100. So they share a point. All right, so then rise over run. And it's good to write rise over run all the time so you remember what you're supposed to be doing, would be 300 minus 100. So that's the difference in the y numbers over the difference in the x numbers. So that's 4 minus 0. So that's $200 over 4 months. And then 200 divided by 4, that's 50. So that's $50 per month. So Telus has a lower rate of change than Bell. Now we can see that on the graph, right? Because the Telus graph is less steep, whereas the Bell plan is more steep. So really, the steeper the line, the greater the rate of change. Okay, so visually inspecting the graph, you'll be able to tell which one actually will have a greater rate of change right away if you've got 2 graphs on the same axis. So let's take a look at the success criteria for calculating rate of change. So remember, you're going to first pick any 2 points along the graph, and we're going to write them as an ordered pair, and then you're going to calculate the ratio of the vertical distance to the horizontal distance. So in other words, you're going to calculate rise over run. So remember that rise over run is the difference in the y values divided by the difference in the x values. All right, we're going to take a look at fictitious Jack and Jill, and apparently they save money. So what we're going to do is we're going to calculate the rate of change in savings for both Jack and Jill. Let's take a look at Jill first, okay? Ladies first. So we're going to pick any 2 points along the graph. So that's easy to pick the first point and then just pick any point that's easy to read. Well, let's just go right over here. So we've got those 2 points here, and then if we write them as ordered pairs, the point over here we can represent as 8, 500. And then the second point we can write 0, 500. So if we calculate the rise over run here, rise over run, well, that's equal to 500 take away 500 over 8 minus 0. Well, that's going to get me 0 as a numerator and then 8 as a denominator. And that's dollars and that's months. So 0 divided by 8, well, that's just $0 per month. So when a line is flat like this or completely horizontal, there is no change, right, in the savings. So that's why the rate of change would be $0 per month. Now if we look at Jack, and if we pick any 2 points, so let's pick that point there and the point in the very beginning, let's represent those 2 points as ordered pairs. This point here would be 8, 1000. And then we've got a point 0, 1400. All right, now when we calculate the rise over run here, okay, we're going to find the difference between the two. And just like the example on the top, we'll do the top number minus the bottom number. So it's actually going to be 1000, take away 1400, and then divide that by 8 minus 0. So actually on the top, we're going to get negative $400 over 8 months. And so if we divide those two values, you're going to get negative $50 per month. So actually, he's not saving money, he's losing money. And we can actually see that on the graph if we inspect it carefully. He starts with $1,400 and he's actually losing money along as time goes. So he's not saving money, he's spending money. So his savings is actually decreasing. So when we have a graph going downwards like this, the rate of change is actually going to be negative. All right, in this example here, we've got a set of axes here as well as a table of values. So we're going to graph the data from the table, and then we're going to calculate the rate of change. So this data involves time worked and earnings. So at 0 hours, this person earns $50. After 4 hours, they've earned $100. After 8 hours, they've earned $150. After 12, they earned $200. And after 16 hours, they made $250. All right, as you can see here, this creates a straight line, so we're going to just connect them. And we can calculate the rate of change. So let's pick any 2 points. Let's pick the first point and the last point. So the last point here, we can say that's 16, 250, and then we've got 0, 50 for the first point here. So let's calculate rise over run. So 250 minus 50, so that's the difference in the y numbers, divided by the difference in the x numbers, so that's 16 take away 0. Well, that's 200 divided by 16, and that's dollars, and that's hours. So let's figure out what 200 divided by 16 is, and that's 12.5. So that's really $12.50, right, per hour. Now, what's really important here is that we picked 2 points along the graph, and we looked at the set of axes. But actually, we can also look at the table of values. You see, we picked 16, 250. Well, 16, 250 is actually set up for us right here. I mean, if I drew the comma and the brackets here, there's a point right here on the bottom that's laid out for me. Also, 0, 50 is on the top. You see, so the table of values actually is just a series of points that we can use to calculate the rate of change. I just happen to pick the top one and the bottom one. So let's calculate the rate of change for each of these tables of values. So remember, each row in a table of values is written like an ordered pair. Okay, so all we need to do is just pick any 2 points. So again, in this example here, this is the exact same table as the example before. But if we pick 2 different points, we're going to get the exact same answer. Let's pick these 2 points right here. So if we do rise over run, and for these points, well, that's going to be, let's just go top minus the bottom again, just for fun. 100 minus 150 divided by 4 minus 8. Okay. That'll get me negative 50 on the top and negative 4 on the bottom. Well, if I do negative 50 divided by negative 4, I get 12.5 again. Right? So I get $12.50 per hour again. Okay? So I could have done 150 minus 100 and then 8 minus 4, so I wouldn't get the negative numbers, but I would still get the exact same number. Okay, so as long as you're subtracting consistently, like top minus the bottom or bottom minus the top, it actually doesn't matter. Okay, so let's look at example B. Actually, you're going to do this one. So again, pick any 2 points on this table, and then calculate rise over run. Okay, so pause the video, give it a shot, and then press play when you're ready to check your work. Good luck. All right, so let's pick, I'm just going to pick the first one and the second one. Okay, if you pick 2 different points, don't worry about it. We're going to end up at the exact same answer, I hope. So rise over run. So let's do, I'm going to go bottom minus the top just to switch things up. So I'm going to go 800 minus 1200. And then I'll do 20 minus 0. Whoops, 20 minus 0. All right, so 800 take away 1200. Well, that's negative 400 over 20. Oh, and that's 800, those are meters. And then the 20 and the 0 were minutes. So I'm going to write the units down here as well. So negative 400 divided by 20, let's let's go negative 400 divided by 20. Okay, so that'll get me negative 20. Negative 20, and that's in meters per minute. Okay, so it's great to write units down here so that you can make sense of what the rate of change actually means here. So whatever this is, it was decreasing at a rate of 20 meters per minute. Okay, so hopefully now after this video you know how to calculate the rate of change between two variables when you're given a graph or a table of values.